Hello, lovely people. For today, we are going to look at how to sketch cubic function graphs, or what we regard as the graph of polynomials. We have a question here, which we can also use to touch other parts and other things needed in a cubic function. Question says we should sketch the graph of f of x if f of x is equals to x cubed minus 6x squared plus 9x. And we should also indicate all the intercepts and points. And after that, we'll go through the second question and then the third question. Here, the graph, when we have an equation, we check. We have many methods or different methods of solving cubic equations. We have the solving by factorization, by inspection, by long division method, and the synthetic method. But always check if you can solve a problem using the factorization method before you start trying the other ones. Now, let's go straight to this. What do you need to sketch a cubic function? A cubic function graph will appear like similar to a sine graph if it is positive, or if it's negative, we will have something like this. Or in some cases, we also have a shape that is like this. We will explain those concepts whenever we encounter them. Now for this, what do we need? We need the x and y intercepts. We need the stationary points. We need the point of inflection. With this method, we can easily sketch the cubic function. So how do we go about this? The normal approach for x and y intercepts, make y 0 or make x 0. So first of all, let's go to x intercepts. For x intercepts, in the function we make y 0. And then we check which method will work for us. Now, let's try factorization. If we take out x, that's the common factor, we have x squared minus 6x plus 9. We check if this is factorizable, this is a trinomial. Let's see if this is factorizable, so we have x into x minus 3 and x minus 3. So this is factorizable, we will return 3 values of x, which is normal for a cubic function. So the values of x in this case will be 0, we have 3 and 3, so we have 3 twice. Let me explain to you what happens when we have the same value of x-intercept. It is the same thing. It means that x-intercept will also serve as the turning point. We will see clarity when we go forward. So we have our x-intercept. So let me write down the coordinates. If x is 0, y is 0, the second is x is 3, and y is 0. And x is 3, y is 0. Same point. Now let's go to y-intercepts. Y-intercept is always a constant for every equation. Here we don't have the constant. It means our constant is 0. And remember, when at x-intercept y, at y-intercept x is 0. So this also serves as our y-intercept. So this will be our y-intercept as well as one of the x-intercepts. So we've gone through the first one. The second one is our stationary points. So let's go through our stationary points. Stationary points is the same thing as the turning points. If you look at this graph, it has 2 stationary points. So the turning point for this will be 2. How do we get our turning point? To get our turning point using calculus, the first derivative will be equated to 0. The first derivative of the point function must be equated to 0. So let's go through that. First derivative, remember, if we have the function of ax to the power of n, the first derivative of this will be n times a. And then we have xn minus 1. This is the general rule for first derivative of any function. This is general rule for differentiation of equations. Now we go to our days. So this is going to be n. It is 3x, n minus 1. So we have 3x. 3 minus 1, that's 2. For this also we have 2 times negative 6 is 12. Negative 12. X minus 1 is 2 minus 1 is 1. Then here also we have 1 minus 1 is 0. So we have 9. Because anything raised to the power of 0 is 1. We don't have a constant. So this is the first derivative. We equate it to 0 to solve for our stationary points. So what do? We try simplifying this to get the x values of our stationary points. 3 is a common factor. I can take them out. Half x squared minus 4x plus 3. And then I'll check if this is factorizable. You can also factorize using the whole thing. Now, here I have minus 3 and minus 1. Gives me minus 4. Minus 3 times minus gives me this. So the two values of x is 3 and 1. I have gotten the values of x for my stationary points. So for this, for my stationary points, I have 2 coordinates already in the builder. I have 3 and 1 as their, I have 3 and 1 as their x values. How do I get the y values? Take these x values and sub them into the original equation. Please be mindful, not into the first derivative equation, but into the original equation to get the corresponding values of y. To get the corresponding values of y. So, let's go there. If I solve, let's start with 1. I have 1 all cubed minus 6 times 1 plus 9 times 1. That will give me 1. Minus 6 is minus 5 plus 9. That is 4. So for this, the y is 4. Let's go to the second one. I have 3 all cubed minus 6 times 3 all squared plus 9 times 3. This is 27 minus 6 times 9. 6 times 10 is 60. So 6 times 9 is 54. Plus another 27. So 27 plus 27 is 54 minus 54, 0. If you look at this, this is the stationary point. It's corresponds with one of the x-intercepts. So whenever you have a double value or the same point being repeated for an x-intercept, know that that will serve as one of your stationary points. Now, what else do we need to complete our graph? On this graph, you will see that there's a point that joins this part of the curve to the other curve. That is where we classify as our point of inflection. How do we get our point of inflection? Point of inflection is gotten by equating the second derivative of that function to 0. So, this is our first derivative. This is the function. First derivative gave us 3x squared minus 12x plus 9. This is our first derivative. Second derivative, differentiate again. We have 6x minus 12. The derivative of a constant is 0. So they said second derivative, equate it to 0. Equate it to 0. So if we solve for x here, x will be equals to 2. So, for our point of inflection, we have x as 2. We need to get the y value, just like we did with stationary points, sub it into the original equation to get your y value. So, we have 2 to the power of 3 minus 6 times 2 all squared plus 9 times 2. That will give us a y value of our point of inflection. So, this is 8 minus 6 times 4 is 24 plus 18. So 24 plus 18, 8, 24 plus 8 plus 18 is 26. minus 24. 26 minus 24 is 2. So we have our point of inflection as 2 and 2. That is our point of inflection. Now, let's sketch this graph. Let's sketch this graph. The highest value I have so far is 4, so I can go to 4, 6, and the same place using proper calibration. The grid lines I will provide for you will guide you. So let's represent our points. I have 0 and 0. I have 3, which is my x-intercept and which will also double as my stationary point. And then I have 0 and 0, 3 and 3. My y-intercept is the same thing as this. So what do? I will have to replace my stationary points. Let's see. The first one is 1 and 4. So I have this point. The second one is going to be here. Now, this is a positive graph. So this will guide us to know that this graph will have to go up and down. If not, there is also another way of figuring out which one is going up, which one is concave up, or which one is going to be going down. How do we figure this out? If our second derivative is greater than 0, then we know that we are going to have a concave up. If it is less than 0, we know we are going to have a concave down. Our second derivative, we had 3x squared, which was 6x. We have 6x, and this is, so we have 3x squared, sorry, I should have placed this down, minus 12x, plus 9, first derivative, second derivative, 6x minus 12. So 6x minus 12, that's our second derivative. When it is greater than 0, we know. When it is greater than 0, we know we are having a concave up. And when it is less than 0, we know we are having a concave down. So those two conditions, remember, is very important. So this will go down, concave down, and this will go up. But for this graph, just to save time, we are going to go straight because it is explicit enough. So because we know that it's a positive graph, this will be the graph. What did we miss? Our point of inflection is at 2 and 2. Look at this. If it's not at 2 and 2, you must have made a mistake. So this must be taken into consideration. You can't just draw a curve. So we have 2 and 2, that is our point of inflection. So your graph must also flow through your point of inflection for you to have a perfect cubic function. Now, because of our time, let's look at the other things here so that we don't create a video that you struggle to watch. Now, determine the values of x for which f of x increases. F of x increases only when your first derivative is greater than 0. Alternatively, f of x increasing function relates to when your y and x value are increasing on the graph. You don't even need to solve anything to get it. If you look at this, x value is going towards the right, that means it is increasing, the value of x is increasing, and it is also going up. Going up vertically means the value of y. So from this point to this point, our graph is increasing. Now, if we look at this, from this point going down to the next stationary point, x value is still going to the right, meaning that it is still increasing, but y value is decreasing. So from this point to this point, we see from here to here, we have a decreasing function. This part, we have an increasing function. This other part, we also have an increasing function. So if they're asking for increasing function, we can say that for increasing function, It is when x is from the starting point here, which is 4 and 1. The values of x is what they are asking. So it is when x is less than 1. When x is less than 1, we have an increasing function. And also when x is greater than, from the next starting point going on, when x is greater than 3, we have increasing function. For decreasing function, we have from here to here. So we say x is greater than 1, yes. When x is greater than 1, then it will stop at 3 and less than 3. That's where we will have our decreasing function. Now, let's quickly go through the last question. They are asking us to determine the equation of the tangent at x equals to 1. The tangent equation must be a linear equation because the tangent to a curve must always be a linear. So at x equals to 1, they are asking you the tangent equation. At x equals to 4 for this equation. Because 1 will fall in between here, yes, that will also be right, but let's take it. At x equals to 1, the tangent equation that passes through x equals to 1. So it will be something like this. The tangent equation, it will be a linear equation. What do? We need the value of x at that tangent point. We also need the value of y at that tangent. And then, based on the equation, we also need the gradient at that tangent. Also remember that the first derivative of any function is also equivalent to the gradient of that equation at that point. So, how do we go? We've been given x equals to 1, so that is our x of t. Sub this into the original equation. So, we are looking at f of 1. So we have 1 cubed minus 6 times 1 squared plus 9 times 1. So this gives us 1 minus 6 plus 9. 1 minus 6, that's 5, plus 1, 4. Already that's a point on the graph. So we have 4. So the coordinates 1 and 4 is what we are going to use to figure out the equation of that tangent line. Now, what do we need next? We need the gradient equation. So we need first derivative when x is equals to 1. The first derivative of that function when x is equals to 1, our first derivative is 3x squared minus 12x plus 9. So sub in 1 into the first derivative equation to get the gradient needed for that line. So this is 3 minus 12 plus 9. 3 minus 12 plus 9, and that will give us a 0. What does that mean? That was why initially I wanted to change this, because we have a 0. We have the gradient is a 0. And if the gradient is a 0, what does that mean for the graph? Remember, it means we are going to have a horizontal graph. We are going to have a horizontal graph if the gradient is 0. So this gives us a 0. So if we solve this into the equation, we have y equals to mx plus c. Our graph is going to be, if we solve y and 4, our gradient is 0. Because 0 times x, 0 plus c. And we will have 1 and 4. So finally, y is equals to 4. That is what the equation of the tangent is going to be. So to sketch that graph, we have a horizontal line that runs from y, and that is the tangent equation for this. So the tangent equation at this x equals to 1 will give us y equals to 4. Please continue to share the video, continue to ask questions, continue to encourage your friends to subscribe. I will see you in the next video. Enjoy the rest of your day.